Ever wondered what would happen if a particularly strong solar storm hit Earth? To understand that, let's first delve into what a solar storm actually is. Contrary to its tranquil appearance from our blue planet, the Sun is a lively and turbulent star. It frequently releases powerful bursts of energy and charged particles into space, a phenomenon we call solar storms. But how do these originate? Well, the Sun is a roiling sphere of hot plasma, constantly in motion. Sometimes disturbances occur on its surface, such as solar flares and coronal mass ejections. These disturbances propel streams of energetic particles and massive gas bubbles, threaded with magnetic field lines, into the cosmos. Now, what happens when these storms reach our planet? As these particles journey through space, they interact with the magnetic fields and atmospheres of planets they encounter. When Earth is in the path of a solar storm, the particles collide with our planet's magnetic field. This collision can create geomagnetic storms, leading to one of the most beautiful natural phenomena we can witness: auroras. Also known as the northern and southern lights, these are breathtaking displays of vibrant colors dancing across the night sky. But while these storms paint the sky with a visual symphony of lights, they can also interfere with modern technology. These storms are not just about pretty lights. When they're particularly strong, they can pose risks to satellites, power grids, and communication networks. The intensity of solar storms can vary, with some being minor and causing little effect, while others can be so powerful that they disrupt Earth's magnetosphere and ionosphere, leading to significant technological disturbances. So the next time you gaze at the serene sun, or marvel at the dancing lights of an aurora, remember the fiery, turbulent star that's responsible for these captivating displays. And keep in mind that these beautiful phenomena are also a reminder of the sun's power and the potential impact it can have on our modern world. Solar storms are not just about beautiful auroras, they can pose risks to our modern world. For instance, the energetic particles and gas bubbles released during these storms can cause disruptions to satellites. This could affect everything from GPS navigation to weather forecasting, and even the operation of our telecommunication networks. Our power grids are not immune to the effects of solar storms either. Imagine, if you will, a particularly powerful solar storm hitting Earth and causing widespread power outages. It's not just a brief blackout we're talking about here. These outages could potentially last for weeks or even months, depending on the strength of the storm and the resilience of the affected power grid. The intensity of solar storms can vary, much as the severity of storms here on Earth varies. Some solar storms are minor, causing little more than an increase in the visibility of auroras. However, others can be quite powerful, disrupting Earth's magnetosphere and ionosphere. You see, when the charged particles from a solar storm collide with Earth's magnetic field, they can cause what's known as a geomagnetic storm. This is essentially a temporary disturbance of the Earth's magnetosphere, the region of space surrounding Earth that is controlled by Earth's magnetic field. In addition to causing beautiful auroras, these geomagnetic storms can also lead to significant technological disturbances. For example, they can cause radio blackouts, disrupt satellite operations, and even affect the operations of power grids and pipelines. So, as you can see, while solar storms may paint the sky with breathtaking displays of color, they can also have a profound impact on our modern world. The severity of these celestial disturbances can disrupt Earth's magnetosphere and ionosphere, leading to significant technological disturbances. This is why understanding solar storms and their potential impact is so crucial in our technology-dependent society. But how do we measure the intensity of these solar storms? A crucial question to ask indeed. To tackle this, allow me to introduce you to the NOAA Space Weather Scales. This standardized system was developed by the National Oceanic and Atmospheric Administration, or NOAA, to rank and categorize the severity of space weather events, particularly geomagnetic storms. Imagine the scales we use to measure the intensity of tornadoes or hurricanes. The NOAA's scale functions similarly, providing a clear framework for understanding the potential impact of these celestial disturbances on Earth and its technological infrastructure. The scale ranges from 1, denoting minor storms, to 5, indicating extreme events. Each level corresponds to the potential impact on power systems, satellite operations, and other technological systems. It also takes into account the visibility of auroras, those mesmerizing northern and southern lights, at specific geographical latitudes. So what does each level mean? Well, a minor storm rated as a 1 on the NOAA scale can cause weak power grid fluctuations and minor impact on satellite operations. Moving up, a moderate storm, rated as a 2, can cause high-latitude power systems to experience voltage alarms, and longer-lasting storms may cause transformer damage. When we reach a 3, denoting a strong storm, we're looking at potential widespread voltage control problems, and some protective systems may mistakenly trip out key assets from the grid. At a 4 or severe storm, we can expect possible widespread voltage control problems, and protective systems will trip out key assets from the grid to protect them from damage. Finally, we have the Level 5 extreme storm. In this case, we're talking about complete grid system collapse or blackouts, and damage to transformers could take years to repair. These scales aren't just for scientific curiosity, they play a vital role in our modern world. By using this scale, NOAA aims to provide clear warnings and timely information to stakeholders, ensuring preparedness during significant solar events. It's a stellar way to keep tabs on our fiery celestial neighbor and its potential impact on our technologically driven lives. Let us travel back in time to the 19th century to explore the largest solar storm ever recorded. On a seemingly ordinary morning, Richard Carrington, an amateur astronomer, ascended the steps to his observatory nestled within the tranquility of his rural London estate. The sky was a clear, inviting blue, perfect for his daily observations. He aimed his large brass telescope towards the sun and began to sketch the sunspots that danced across its fiery surface. It was during this routine observation on September 1st, 1859, that Carrington noticed 2 points of light emerging amidst the sunspots. They intensified, blooming right before his eyes. 5 minutes later, the blinding flares dissipated. Unbeknownst to him at the time, Carrington had just witnessed the largest solar flare in modern history. This white light solar flare, which would later bear Carrington's name, was actually a magnetic explosion on the sun's surface. It was so powerful that it briefly outshone the sun itself. Within a few hours, the effects of this colossal solar storm were felt on Earth. The skies erupted in brilliant hues of red, green, and purple. These lights, while beautiful, were indicative of the immense energy released by the flare. The Carrington event, as it came to be known, had significant impacts. Telegraph systems across Europe and North America failed, some even shocking telegraph operators. Paper in telegraph offices spontaneously caught fire. The world got a taste of what a solar storm of this magnitude could do to our increasingly technologically dependent society. But with this event also came understanding. Carrington's observations paved the way for further studies into solar storms and their impacts on Earth. It highlighted the need for preparedness against such natural phenomena, especially as our reliance on technology grows. Carrington's observation led to the understanding of the largest solar flare in modern history, forever changing our understanding of solar storms. So, what have we learned about solar storms? We've uncovered that solar storms are essentially disturbances on the sun, involving solar flares and coronal mass ejections. These powerful outbursts release streams of energetic particles and massive bubbles of gas threaded with magnetic field lines into space. When they interact with Earth's magnetic field and atmosphere, they can cause geomagnetic storms that result in spectacular auroras, or the northern and southern lights. However, the beauty of these natural light shows is accompanied by a potentially destructive force. Depending on their intensity, solar storms can interfere with satellites, power grids, and communication networks. In some cases, they can cause serious technological disturbances, disrupting our modern way of life. To better understand and prepare for these celestial disturbances, the National Oceanic and Atmospheric Administration, or NOAA, has developed the space weather scales. This system ranks the severity of space weather events from minor to extreme, based on their potential impact on our technological infrastructure. By using this scale, NOAA provides clear warnings and timely information to help us prepare and mitigate the effects of significant solar events. And then, there's the Carrington event. This largest recorded solar storm in modern history, witnessed by Richard Carrington in 1859, was a powerful reminder of the sun's influence on our planet. The event caused brilliant auroras to erupt all over Earth and disrupted telegraph systems, giving us a glimpse of what could happen if a similar event occurred today. So, while solar storms are a marvel to observe, they are not without potential dangers. However, with a better understanding of these events, we can work towards enhancing our preparedness and mitigation strategies. This, in turn, will help us ensure the continuity of our technological systems and daily lives, even in the face of such powerful celestial phenomena. While solar storms can be a threat to our modern world, understanding them better can help us prepare and mitigate their potential impacts.